we're not getting into that today. All right, questions about your homework. 23. 23. 23 was a good one. Listen. Okay. So with 23, I've seen this kind of thing come up occasionally, so I really wanted, I meant to talk about it yesterday and I didn't. If you look at it, it looks dangerously close to, it's not 1 minus its x, no, it's 1 minus x squared, right?
I don't understand these things. But like
that doesn't, yeah, but that doesn't do anything for it. Okay, so here's what I did, because this is the property, right, and this looks really close to it, I can force that to happen. If I factor a 16 out of these two, I understand that one doesn't have a 16 to give, but if I have this, if I take a 16 out, it leaves me 1 minus 1 over 16x squared. Right? Now if I distribute back, I get back what I started, right? Are y'all following with me? That's not that, but it's really close, because I could write it like this, and now it is like this. Now remember, this is all under a square root. Square roots can be split up, right? So this is like the square root of 16 times the square root of 1 minus 1/4 x squared. The square root of 16 is 4. So this is like 4 times the square root of 1 minus 1 over 4x.
there's only going to be one of these problems from AP exam, guys.
Because I squared it. So when in the equation, that whole term is squared, right? So I'm thinking of what I could plug in for my u. This is actually inverse sine. So now what I can do is this could be written as the integral of 1 over 4 times the square root of 1 minus 1/4 x squared. Now my u is 1/4 x, which means my du is 1/4, which, look, I have that in here, so nothing even has to be countered. So this becomes the integral of 1 over the square root of 1 minus u squared, which is inverse sine of u. No, e. You don't counter it with anything. So now what, because this is inverse sine of u, integral is inverse, is antiderivative.
I just asked that. Did I not?
I don't know what you asked. Now you're confusing me. Ask me what you asked me again. Yes, that is correct. Yes, yes. I apologize. Yes, yes, yes. So now I replace the u, so inverse sine of 1/4 x. I don't need it to be c, because c's got the 1/4 in front, so if you thought that you countered it, you would have gotten that, but you don't have to count. What else? 5, did you say 5? No, it's not.
3, bro. I said 3. I sung it for you. You said 3 conquer 4.
Yeah, I will. I will.
3.
All right. Let's do page by page. Page 1. Page 1. Page 1. Page 1. 3. Yeah, we're doing differential equations today. It's gonna be so much fun. How do I move? All right, u. I'm gonna let u be the square root of x minus 1. I'm just saying, you told everybody you like Christina Aguilera yesterday. That was your favorite. All right. I need a 1/2 inside. I'm going to counter it with a 2, and I have everything I need. So now I have 2 times the integral of u squared du. Oh my gosh. Yes. No. That's whenever you have numbers. I think that's what you're talking about. Du, so yes, when you do du, this is never in the bottom. It just is what it is. I know what you're talking about because it was one of the inverse trig ones. So it would have been like this one, whereas because the du was 1/4, and this 4 isn't. That's not a 4 in the bottom. That's actually a 1/4 because it's. So it would, if you had to counter it, you would counter this with a 4 out here. Even though everything you're working with is in the bottom, it's 1 over whatever. It's still as a whole, if that makes sense. Okay, which other one? 5. 5 you have to write as cosine over sine. If you do that, the answer should pop out. Always make the denominator be your u. So du would be cosine 3x times 3. I need a 3 here, which means I need a 1/3 here. So I get 1/3 times the integral of u to the negative 1 du, which is the natural log of u is sine 3x. Where I lose you? Tangents and cotangents always change to sines and cosines. So you got cosine, you got du over u. U being 3x will not let you solve this one. Because then you'd have cosine u over sine u. And that's not going to, you don't know the antiderivative of that. What? No, it's not. It's natural log of the sine. This one? What x in the numerator? 1/4 x is the same thing as x over 4. Yep. Jerk. Jerk, jerk. We got one more lesson. I think right now I have it tentatively scheduled.
Friday, no, Friday, that's next Friday. Definitely. He'll call you.
What's going on? I'm always good with earlier. Thursday?
No,
Okay. Okay, we'll have to do it on Thursday.
No, it's past the 13th.
Oh yeah, today's the 17th.
No, I was playing a joke on it.
Next Friday.
All right, how about back of the first page? No. I don't believe either one of you because you are a bad influence on him, who was always, yes. Three. Oh, sorry, 3. Sign over. Because I was fixing to say, I told you to turn the page over, but then I realized that the numbers started over there. Okay. No, I think y'all just say things sometimes just to make me, like, question my sanity.
No, I'd like to formally apologize.
It's okay, Liza. It's okay. It's okay. To who?
No, it was Slade.
Something made us remember yesterday to do a multiple choice quiz.
Okay, so if you're confused on what to make what here, my gut instinct on this one was to make u be 1 plus cosine squared x. But if I did that, if u was 1 plus cosine squared x, that means du would be 2 cosine x sine x negative sine x. I don't have that available. Yeah. Yes, it could be sine. Yes, it could be sine. Nope. It's cosine squared plus sine squared equals 1, not 1 plus. Davis, what were you going to say? You can make u be whatever you want, so long as whenever you do it, the du is contained. In other words, if I do this, right, what I end up with, you can't take the squared away, so this is going to be, I need a negative, right? I need a negative to counter. Du over 1 plus u squared. The square is still there. You might get confused since you started with x. Okay. If you want to. Could you make your u x, like say x equals cosine x, and dx equals negative sine x? Anytime you see something in the form of 1 over 1 plus something squared, or 1 over the square root of 1 plus something squared, or this is a perfect square, these are all inverse trig functions. So you're trying to get them to look that way. So for this one, you look at your green sheet. What is it? Inverse tan. It's inverse tan. I'll just look at Anna. She'll tell me. Anna and Liza. The truth to the table behind them. Sure. You bought them. All right. Questions, other questions about that page. Okay, flip it over. 17. Everybody keeps asking. Oh, that's not on the. Let's do 17 because everybody's asking about 17. Maybe I did 17 wrong. Okay. How do I move? Okay. I did not. So there are several problems that you will encounter that it's easier to do manipulation first rather than after. I think back to like pre-cal when you were doing rational functions because my kids just did that. Sometimes before you multiply, add, or subtract, it's easier to simplify each fraction first and then do what you need to do. The same is true here. So if you can ever simplify before you start, it'll make your life a little easier. Now, I'm assuming this is where y'all got lost on this one because I changed secant to 1 over cosine. And I changed tangent to sine over cosine. Does that make sense? Roll with me? Flip what? Make what negative? I've not done antiderivative yet. You don't know secant tangent. What? Oh, you actually could. You actually could. I didn't recognize that. Yeah, you could. Yeah. Is that the way you did it? Okay. I am in the habit of getting all sines and cosines whenever I do it because whenever I took calculus, we didn't memorize anything except sine, cosine, and tangent, and then we were able to manipulate everything else from there. So I have just been ingrained with making everything just sines and cosines to make my life easier. But if you recognize that okay, what is the derivative of secant x? If you recognize that, I did not write off, then this is the antiderivative. You could let your u be 2x and your du be 2, counter it with a 1/2, right? And then you've got, okay. So y'all did that. I made it sine 2x over cosine squared 2x. If you got confused with my key, I let u be cosine 2x, which means my du was negative sine 2x, and then I had to chain it. And this is more work, and I realize that, but it's what makes sense to me whenever I do it. I change it to sines and cosines because I understand sines and cosines better than I do secants, cosecants, tangents, cotangents, and all that. So either way you want to do it, it doesn't matter. Which way do y'all want me to do it? The first way. Okay, so this is the way that's on the solution guide, so I'll do it this way over here. Or I'll do it y'all. So I've got 1/2 times the antiderivative of secant x tangent x we said is secant. And remember, this is a u now, so it's secant u. If you do u, you're going to have to adjust these bounds. Okay? If you put 2x, you don't have to adjust the bounds. Don't adjust both. That's the biggest mistake I saw y'all doing yesterday. Don't adjust both. Adjust one. So if I keep this as a u, then I'm going to need to plug into this equation. So 2 times pi over 8 is pi over 4. 2 times 0 is 0. So now all I have to do is 1/2 times secant of pi over 4 minus secant of 0. Secant is the flip of what? Cosine. What's the cosine at pi over 4? So the flip of that is square root 2. Secant of 0, so the cosine of 0, 1, the flip of that, oh, that's not what I got when I did it the other way, is it? I probably am on that one, because this is definitely right. This is square root of 2 over 2 minus 1/2. That's my final answer. What? That's heat. It's warming up. I just have the heat on. That's how I know it's heat. I don't have it on auto. Yeah. Okay. This ends up being 1 over 1 plus u squared, which is inverse tangent. Okay. Yeah, and now I'm going to adjust my bounds. 1 to negative 1. Remember, inverse says where is tangent that value? So where is tangent 1?
Where you keep flipping it up, Dave. Keep doing this. Why is it not 1/3 on this side?
Because du is 3 dt. So I counter that on the outside. What? If you multiply down here on the bottom by 3, you've multiplied the whole thing by 1/3. It's a fraction. All right, which other one did y'all say? Oh, hey, brother. Where is tangent 1? Where is tangent 1? Pi over 4. Where is tangent negative 1? Here's where you have to remember that domain restriction of inverse tangent. Inverse tangent runs from negative pi over 2 to pi over 2. So you got to stay in this area. Negative pi over 4.
I got 0. Let's go.
No, you didn't. No, you didn't. That is not 0. It's pi over 6.
Oh. That's the whole bottom.
Oh, look, I got that one wrong too. I didn't counter it. A jerk. Don't fall into that, Anna. It's a slippery slope. Start out just with a little white lie there, trying to trick your teacher into thinking the board's off. Before you know it, you're smoking crack in the bathroom. That's right. In a van down by the river. What? Do you get it? Can I what? Sure, I've been distracted. Yeah, on your Christmas money, what? Oh. Because I said it's only 13. Yeah, you make u whatever you need it to be so that it can be an antiderivative.
Okay, so I got 1 over u.
Okay, wait. But if you let u be 1 plus 9t squared, what is du? 18t. You can't just throw a t in all willy-nilly because you want to. You can only do whole number, like numbers, coefficients. Right. You can make it whatever you want. Those are hard.
Like, I'm supposed to just recognize when I can just, like, make it whatever I want.
If you start seeing perfect squares in the bottom that are added and there's just two terms, that's what you start thinking. Yeah. Okay. For this one, I would let u be log x. I would let du be 1 over x dx. Kenzie, just hush.
And look at that, it says I'm taking you in class.
Kenzie, you asked for this 15 times. It's u du, and I am going to adjust my bounds because there's a u in there. So this is going to be the log of 1 is 0, the log of e is 1. Oh my gosh.
Goodness, Kenzie. That's her daughter.
Log and e cancel, it leaves you with 1. Log anything this is 1, e to the what power is 1, it's got to be 0. One half u squared from 0 to 1. I hell. I told you to never say that in public.
Jar Jar Binks is her favorite
Star Wars. You watch Star Wars?
Please,
No, we're not having this discussion in here because we've had it at home many times.
I'll pull it up and walk around the class.
One half.
Good. Stuff.
That you know and throw extra variables in there and see it test your knowledge of definitions that way. This is kind of this kind of problem. So what I did was I first said, okay, can I evaluate the left side? Because here I've just got a number. Is this going to give me something that I could evaluate? So I try to use sub, and I said, what if u is x squared plus 6? That means du would be 2x. Means I need a 2 and a 1 half. So I end up with 1 half the integral of du over u. I adjusted my bounds. So I plugged 0 in here, I plugged k in here. So I got k squared plus 6, and I got 6. I know that this equals 1 half log 6. Okay. 1 half, this is the natural log of u, absolute value of u, from 6 to k squared plus 6. Here's where you probably, well, this I'm going to mark out because it's on both sides. B.
What's here?
Did you?
I got it.
You
That
said
was
B? Well, they're all.
Divided it on both sides. Remember, I'm solving for k is what I'm doing. And I don't know if y'all remember back in pre-cal when we solved these kind of log equations. I'm going to add this over here so that I get 2 of these. Now remember, 2 log 6s is the same thing as log 6 squared, which is the same thing as log of 36. So now what I did, this is when the magic happens. You ready, Slade? We'll start doing my magic math now. If I take both sides and I make them have a base of e and let this be the exponent, because e's and logs cancel, okay? This cancels, this cancels. I end up with k squared plus 6 equals 36.
What's your minus again?
Either or. Only take the primary root on whenever
Well, split it up with me. You can break it up.
No, you can't.
What did you say?
Do the roar. All right. I feel like I say this all the time, but we're gonna spend Tuesday. This is usually a full-blown FRQ, and it's a good one to have because you get so many points for doing so many little things with one like this that it's really helpful. Okay. They will say something like, first of all, this is called a differential equation because it is a derivative equal to an equation, and we're going to solve this for y. That's enough. Find the equation for y if x equals 1 and y equals 1. Go. Okay, but the problem is if I do antiderivative now, if I came over here and did antiderivative and I came over here and did antiderivative, can you do antiderivative here? You got a y in there. What you gonna do? You got two variables. No. I'm saying when x equals 1, y equals 1, but find the equation for y. General equation. Your first step is always in here to separate the variables. Get the y's with dy on one side. Get the x's with dx on the other side. And then integrate. I love differential equations. So if you look at this equation, somebody said distribute that exponent, and you could. So I have dy dx equals x squared y squared. If I multiply both sides by dx, I have dy Anybody confused so far? No, what? Yep. Yeah. Pause. Yes. Not x squared over dx because you got to move it to the other side. Is it? Don't plug in yet. Integrate. I told y'all what to do. Then integrate. Once they're separated, I have never seen an AP question where you did not get points for separating the variables like that. 1 to 2 points on an FRQ every single time, just for getting them on different sides, getting the y's with the dy's, the x's with the dx's. Period. Every time. Okay, so I still don't need this information yet. Okay, that information is coming in because whenever I integrate with an indefinite integral, I end up with a what? A c. That's to find my c. That's what that's going to be for. So I'm going to integrate on both sides. This is when the magic happens. What is Now notice, remember we can't integrate without the d, whatever the variable is, and we've got that on both sides now, so we're free to integrate. So this is the same thing as y negative 2 dy, yes? All right. What's the antiderivative of y to the negative 2?
1/3 negative 3.
Whoa. Or either one of those. Yes? What is the antiderivative of x squared? Now, I need that constant of integration. I'm not gonna do it on both sides, because if you think about this just being some arbitrary constant, if I came over here and I said plus c, and then it really doesn't matter, you just need it one time. I could move it around. And now I can plug in. So they always are. Brother, my porch deck's still not done. Come on over. Huh? I'm not done yet. No, I was waiting on everybody to catch up. All right, so I'm plugging in 1 and 1, right? We said x equals 1, y equals 1. So I'm going to do negative 1 over 1 equals 1/3, 1 cubed plus c. So negative 1 equals 1/3 plus c. So what is c? Negative 4 over 3. Now I need my equation, but I need it solved for y, okay? If this is my c, right? All right, so I've got negative 1 over y equals 1/3 x cubed minus 4/3. Oh dear, how am I going to solve that for y? How? What if I wrote it like this? No, when you can plug it into a 4-function scientific calculator. Do you know what to do now? I could, yes, but you're right. We're just going to flip both of them. I could butterfly it. Then I'd have to solve for y, and that's silly. I could just flip both. Y over negative 1 equals 3 over x cubed minus 4. Because the whole goal is to get y by itself. There's my equation. What do you think about differential equations? So what? What? Okay, so your homework over the weekend is going to be page 372, 1 through 10, but that's all we're doing the rest of class. So I'm going to work another 1 or 2 with you. Oh, no, it's not. Today's Friday. I have all my jeans today. Jean day. We can't carry them over to second semester, and no one said that. I'm a little bit pressed about that. I bought jean passes. And you can't carry them over. Well, you got them whenever you bought the tickets for the thing. Let's do 7. It looks fun. Well, what day is Tuesday? Oh, yeah. The 21st. I did not forget. I can't tell you. No, you can't see. You know why you can't see? Let me tell you. Yes. What shall I do? Wait a minute. I wrote it wrong. Notre Dame. They got a new quarterback. All right, I gotta get them separate. How do you even start this? Okay. I know. It was. Notre Dame's still gonna beat them, but I did appreciate that. Okay. Kenzie. What are you talking about? Why does she do that stupid stuff like that? Like I do too. Oh. Can I do that? Actually, I can, and that's why I was. When you rewind back to algebra 2 and those properties of actually algebra 1, then algebra 2, those properties of exponents, if you're multiplying with the same base, what do you do with the exponents? You add them. All I'm doing is the backwards of that property here because I need to get the x and the y separated. So I'm going to multiply by dx on both sides so that I have dy equals cosine x e to the y sine x. Oops. Now the only thing I have to do is get that e to the y on the other side. How? Divide it. So would it confuse you if I did this? I'm going to have to do a u sub on both sides. What? Well, unless you just know that would be negative e to the negative y. What's the antiderivative of e to the negative y? But with the chain. So that's where your u sub's coming in. If you did u is negative y, then du would be negative 1 dy. So you'd have the negative, the integral of e to the u du. which would be negative e, and your u is negative y. Okay. I picked the harder of them to do with you. So yes, u would be sine, which means du would be cosine, which means what I have is e to the u du. I think it is, as thinking of it, and then you, but you might not. Yes. Do you know what the antiderivative of cosine x e to the sine x is? No. That's why. Okay. Let's see. This is negative 1. E to the, what's the sine of 0? 0. So I got negative 1 equals 1 plus c. C is negative 2. Let's stop at 7. Let's go 1 through. Let's do odds. Let's do odds. Which one, 2? Okay. Which packet? The packet we're doing now that we're in the last section of? Is that the packet you mean? You've been using your book? We got to solve for y. That's why, listen, when these are in FRQ, when we're going to look at this Tuesday, when these are in FRQ, like, your part A is worth like 5 or 6 points, and it is just solving for the y this way. And then you use that to answer the questions, like it is the bulk of the question. I always do this. I get rid of that negative if I can first. And then, yes, I'm going to log both sides. So if I log both sides, log. I'm actually going to split it up too. I divided both sides by negative 1. If I divide this side by negative 1 and this one, it changed all the signs on the right. I am actually going to make this log of 2 divided by the log of e to the sine x. Subtracting, because I'm doing the log of this whole side. I'm doing that because log and e cancel each other out. So I would just end up with negative y equals log 2 over sine x. So remember those log properties? No, don't do that. Don't do that. Shut up, Stacy. Shut up. You condense it down to, don't do that. I know. Don't do that. The Stacy. You don't condense to write log more than one time. Okay. Keep it like it was. It's e to the negative y. Oh, no, just negative y equals the log. Leave it like this. Yes. No. Because here's the property. The log of A minus the log of B is the log of A over B. You only write the log one time, not twice. Brain fart. Yeah. You don't think I'm right? Okay, I can take it. I can take it. Bro, I have not been to the grocery store. I'm sorry. I'm sorry. I'm sorry. When I pack lunches, I throw extra stuff in Kenzie's that I find. It's been fend for yourself at the McGee house for quite a while.